Welcome to Lab 2.3, working with, well actually we're going to be measuring work done by an electric motor. We're going to measure the amount of work that's put into the motor and then also the amount of work that's the motor's going to put out. We'll use both those quantities to go ahead and figure out an efficiency for our motor. Really a nice, exciting lab. You should be used to a lot of this equipment by now, and it could be a fun lab and it could also be a real dangerous lab. But a bit of equipment that you should be used to using by now are our support blocks, along with our support rods that are going to thread in there, and our long crossbar that's going to go across our setup right here. So, of course, to tie those down, we will need our rod connectors. Now, you will need a total of 3 rod connectors, 2 just the way they come in the box, and then 1 set up with a hook bolt. So we'll use 3 of these. 1 with the hook bolt. We will need the single pulley with a bracket. This will be found in your hardware and measurement cabinet. We will need a stopwatch, a timer. These are found in your hardware and measurement as well. And somewhere in, I want to say it's in their special assemblies where we're going to find the spool pulley. Or it's not in the special assemblies, actually. It's going to be found in your hardware and measurement. It's in a black clear box similar to this box right here. You'll find this. One neat feature about this, just like the step pulley you've used before, is there's a way to tighten or loosen this with the Allen wrench, which is something you're also going to need to make that happen. So we'll tighten and loosen this as we need. There is also a hole, and I've already threaded my cord through the hole, tied a knot here so that we can, just similar to the step pulley, is as this turns, it will tie the cord around. So you will need some cordage. So the Allen wrench, tied onto my spool, and it's getting kind of tangled up right here, is my cordage is on one end is attached to the spool, the other end is attached to our hook, our weight hanger, set of weights to put on our weight hanger. We will need a meter stick to measure the heights that this hanger is going to be pulled up. As we move along, the centerpiece of this whole lab is going to be your electrical motor. You should have 2 electrical motors, and so it's labeled a motor / generator. You'll need this, and if you notice, it's similar to the support bases in the way that it is attached to the breadboarding. Now, so all this motor is going to work off some kind of electrical power source. So our power source, of course, we bring this out. It's a heavy, really modern looking piece of equipment, and we will need some leads. Our leads will be your typical plug-in leads to our power source, and kind of special here, maybe you've seen these around before, but these are essentially used for a quick connect to some kind of motor in this case. And so pretty simple is I can snap these in, 1 on each pole, and you know, do you have to worry about which one's what side black goes on, which side red goes on? No, not at the moment. Switching them over would just change the polarity and really the direction of the motor. But as far as, you know, materials, that's essentially what you need. Understand what we're trying to do is find a way where we can calculate the efficiency of our motor. This would be the complete setup for Lab 2.3. What I'm going to go ahead and do, after you get a nice little shot of the complete setup here, is I will go ahead and kind of walk you through a couple things you need for this lab. One of the things you're gonna have to probably start off with is the height, the initial height of your hanger weight. And so luckily my lab partner went ahead and set this hanger right at the floor, so I can use the bottom of my hanger as my 0 point, and the initial height's gonna be 0. But if I had it off the ground right here, I would go ahead and measure the height, the initial height, and that way I can go ahead and find the height that the hanger moves from its initial height to its final height, which is gonna be the top of this table. A good, easy reference point for me. So, in addition to that, I will take the height of the table, and the height of this table is actually gonna be 91 and a quarter centimeters. So I would need the initial height, the final height, that where I'm gonna stop my experiment. In addition to that, when I turn on the motor, I will have to use a stopwatch to time how long it takes for that weight to be raised to the final height. And that can be found in your hardware measurement. Now, as far as anything else you're gonna measure, well, you have to keep track of how much mass is on the hanger. At the moment, I have a 200-gram weight on there, so we know by now that the hanger is 50 grams, so 250 grams are on that right there. I will use that in my calculations as well. So once you have those initial measurements, here's really the procedure you want to take with this. It could be very dangerous. This motor, essentially if you're powering up the motor, it won't stop. It'll keep going until you shut it off. So before you even turn on the motor, what I would do is make sure my power button knob or my voltage knob is counterclockwise. So it's all the way counterclockwise, and that's going to allow me to safely turn on my power supply without any voltage. And when you start the lab, it is very important that you gradually, we're on DC voltage, by the way, 0 to 24 volts in the first button from your left. So it's very important that as I power my motor, I really take my time figuring out how much voltage is actually needed to get the motor to turn. So I'm very slowly turning my voltage knob, and as you can tell on the spool, it's slightly turning, and that's exactly where I want to have it. So I stop wherever the spool started turning. I stop my increase of voltage on the power supply, and I shut it off. That way, when I turn it on the next time, it's already set to that voltage that I had determined was the lowest voltage that would allow me to pull the weight up. And so from here on out, I will not mess with that voltage. That is something I will document on my lab handout as well. So I can already take that to be my average voltage. So you're gonna do this a couple of times, and it takes a couple of people to make this happen, but you have to be in sync with the timer. When the timer and the person pressing the power button are ready, they'll give a countdown, 3, 2, 1, go, and the timer will start, and we'll yell out stop when we reach the height of the table. At this point, you should have the mass that should be hanging from your hanger. You should have measured the height of the hanger from the floor and the height from the floor to our tabletop. Here it's a breadboard. I went ahead and used a tabletop. And all these two are used to really find out the total height that the hanger is going to move. We went ahead and slowly turned our knob to find the voltage. Now, something else we need is a current that's flowing through the motor. So one thing you want to do as you turn on your power supply is a button on the far right. When pressed, it will be measuring your current or in amps. If you press it again, it will come out, and now you're measuring voltage. There's a nice little picture kind of explaining that for you there. So at moments I want to read voltage, at moments I want to read amps. So now what I would do is, we've already measured the voltage that's going to be required to pull up the hanger, and I'll just press that button so that I can measure the amps or the current needed. So as I press that, we will take the current reading, 1.6, and that's going to go on my handout. All right. As far as that, there's a reading at the beginning of the lab that's going to really kind of introduce you into the fact that electrical work is equal to voltage times current times essentially the amount of time that current is flowing through your motor. Now, something I really want to tell you and really stress is the importance of safety in this lab. If you notice, we have a couple components connected, some that are light, some not so light. We have a mass attached to the string. So, you know, the one important thing is the power supply is going to allow the motor to turn. So before I ever turn on any kind of motor, any power supply, I want to make sure I'm going to provide zero volts. And in addition to that, it's very important that you turn this knob very, very slowly to figure out what the minimum amount of voltage is needed to raise the mass. If I were to turn this without even being careful, you would imagine that the spool would turn even faster, flinging this mass across the room into somebody's face, against a window, who knows what. So safety is very important in this lab, and as it is in any other lab.